Welcome to our first chemistry lab of the school year. Lab 1-9, determining the density of pennies. It's with great excitement, anticipation, exuberance, joy, happiness that we begin today our first lab of the 2020-2021 chemistry school year. This video is just intended to give you the background, the objectives behind the lab, what we hope to see in the lab, what possible conclusions we might be able to draw from the lab. Earlier this unit, Unit 1, we saw demonstrations where an experimenter took ordinary base metals and tried to turn them into silver or gold. The base metal he was working with was copper. The question is, could he actually do that? Is it even possible to actually turn one element into another through chemical reactions, or for that matter, the forming of mixtures? And we know that that is impossible at this point in time. Really what happened there is they started with a copper penny and turned it to silver by coating the surface of the penny with zinc, which looks very silvery. So it looked silver, but it was actually a zinc-coated penny. And a chemical reaction is what was used to make the zinc coat the surface of the penny. And then he turned it to gold by melting the zinc outer layer and the copper inner layer, melted it, and those two layers mixed together, where the atoms from the zinc mixed with the atoms from the copper, and that formed a mixture or an alloy, not a compound, a mixture of those things. And the mixture of copper atoms and zinc atoms actually looks a goldish color, and it's called brass. What we want to do today, and this will be done in the last part of the lab, is to prove that the gold pennies weren't actually gold by using a property that we call density. Now, we want to use density because it is a simple and easy way to prove that the gold pennies were not in fact gold. The gold-colored pennies were not in fact gold. And density is a physical property. There are other physical properties that we could use as well to prove that the pennies were not gold, because every substance has its own unique collection of physical properties. Physical properties, as you remember, are those properties that you can explore, look at, without actually changing the substance, without actually using other chemicals to see if a chemical reaction occurs. How a substance behaves around other substances chemically are called chemical properties. Chemical properties would include flammability, reactivity with substances, the ability, flammability once again is the ability to burn. Will it react with acids? How a substance behaves chemically, you need other substances to determine that. The only problem with using chemical changes or chemical properties is that the substance you make will no longer be the substance you started with, because you form a new compound. Or you could take a compound and break it apart. But what you end with would have different chemical properties than what you started with. With physical properties, you do not use any other chemicals. You do not use any other substances. You are just going to make observations or measurements about the substance, and those physical properties can be used to determine what the substance is. Physical properties would include electric conductivity, melting points, boiling points, and so forth. Texture, color, malleability. In other words, can you pound it thin or bend it into shapes? Ductility. Those are all physical properties. Chemical properties would include flammability. I'm not sure why it's listed here under physical properties. How well it reflects light is a physical property. Its hardness or state of matter that it is at are physical properties. But density is also a physical property. Density is the amount of matter crammed into a space. And different metals have different densities. Density is a property that's characteristic of a substance. So in this lab, we're going to measure the density of pennies we need to know their mass, and we would use a balance for determining the mass, and we would need to measure the volume. There are different ways you could measure the volume. You could actually measure the diameter of the pennies and the width of the pennies and put it into a math formula and calculate the volume. Or you could use the displacement method. And in the displacement method, you could drop the pennies into a graduated cylinder. You would fill the graduated cylinder first to a known mark. Then you would place the pennies in the graduated cylinder, and that would cause the water to rise in the graduated cylinder. A solid object will displace its own volume when placed in water. So by measuring what the volume started at before you drop the pennies, the volume that it went to, the final volume after the pennies were placed in there, and subtracting the two, you would know the volume of the pennies. So for instance, if you filled the graduated cylinder to the 20 milliliter mark and you placed pennies in there and it went up to, say, 22 milliliters, then you would know the pennies must be 2 milliliters because the volume of the pennies made the water rise from 20 to 22. So the displacement method, the volume of the pennies would be equal to the final volume, which is sometimes called V2 or VF or V final, and you subtract off the initial volume, which is sometimes called volume 1 or VI or V initial. Once we know the volume, we could divide that into the mass. To find the mass, you would use an electronic balance or another type of balance, and the mass would be in grams and the volume would be in milliliters since we're using a graduated cylinder, and we would divide the two. Very interesting question that we want to clear up in the lab about density. Does the density of a substance change based on how much of the substance you're going to determine the density of? In other words, if we have 5 pennies, all of the same mint, all of the same type or composition, and we have 10 pennies or 100,000 pennies, all of the same type, same mint, same metals or whatever, is the density of 100,000 pennies different than the density of 10 or the density of 5? And that is one thing we're going to try to find out in the lab. Now, a lot of people would assume that the density would go up the more you have. But in today's lab, we want to find that out. We could look here at the different calculations that are showing you the answer, but that's just additional background. In this lab, the experimenter is actually going to do 5 groups of pennies. First of all, he's going to do an experiment with pennies that were minted 1982 or before. He's going to start with a group of pennies. Then he's going to add another group of pennies, group 2, to it. Then he's going to add a third group to group 1 and 2. He's going to add a fourth group to group 1, 2, and 3, and a fifth group of pre-1982 pennies to groups 1, 2, 3, 4. So he's going to do 5 different sets of pennies. Each set of pennies is going to have more pennies in it. So when it says group 1 and 2, it means you kept group 1 on there, but you added a second group of pennies. Here, this 3 means that you added a third group of pennies to the original group 1 and 2. As you add pennies, we know that the mass is going to go up. The more pennies you have, the volume will also go up. So he's going to do more and more pennies each time to see if the density changes. The second thing we're going to try to explore in this lab is there a difference between different years of pennies in terms of their densities? So he's going to do experiments with pre-1982 pennies, and he's going to do a similar experiment with post-1983 pennies. He's going to do the same thing. He's going to start with one group, add a second group, add a third group. He's going to keep adding groups to the original groups to see if the densities of those change. So, and then at the end, we're going to compare the densities of the post-1983 pennies to the pre-1982 pennies to see if those two sets of pennies, to see if those years of pennies have different densities. And if they do have different densities, we might be able to conclude that they have changed the mint of pennies over time. And then finally, we want to prove, are the gold pennies actually gold? And that will be the third thing that happens in the lab. That is going to require a separate video because our experimenter, did not do the density of gold pennies. So I did the density of gold pennies for you. To access that video and to collect that data, click on the density of gold pennies there. To access the video of the experimenter doing the pre-1982 and post-1983 pennies, you will need to click on an entirely different video, which we would find right here at the very top. You'll click on this video. But don't click on that video until you've read the background information so that you have an understanding of what we've discussed in this video. And if you had any questions, hopefully it'll clear it up. And at the end of the lab, you're going to need to look at known density values, because how can we see if those pennies were actually gold unless we knew the density of gold? So here's the density of copper, here's the density of zinc, and here's the density of brass, which is an alloy of gold and zinc. And the density of brass would depend on how much gold, or an alloy of copper and zinc. And in order to know the actual density of copper and zinc, it would depend on how much copper is in there and how much zinc is in there, and it's a mixture. So the density, the reason this little squiggly line is here is it's about 8.4. If you had more zinc in it, it would be closer to 8, or even in the 7s. If you had more copper in it, then it would be closer to the copper's density, because it is a mixture of those two, so the density of it should be an average between those two. So this is just a quick introduction. Again, here's the purpose. Labs start off with a purpose. Then here's the procedure. The procedure is going to explain what the experimenter actually does. The purpose tells you why we're doing it. Here's data. Some of the data has been written down for you just so that you can watch the video and not worry about scrambling. So a lot of that data has been written down or recorded for you already. But then we get to the calculation section, and here is where you'll have to do some calculations. You're going to calculate the densities of the 5 different groups that were used, or 5 different collections of pennies that were used. You need to take this number and divide it into that number. You'll complete those calculations. You'll do similar calculations for the post-1983 pennies. The setup for these calculations is for you, there for you. And then you'll do the density of the gold-colored pennies. And at the end of this, there will be several questions to answer. We have 9 questions to answer on this lab. Answer those questions. And then as soon as you're done with the lab, there are 3 videos to watch, which will take you through the various conclusions that could be made concerning the lab, what we learned from the lab, and you will also find an answer key for the lab to double check your work. So enjoy our first lab. I recommend wearing safety goggles to protect your eyes during this lab. Even though it is a video, if an accident happens, we wouldn't want anything exploding through your laptop and damage your eyes. Enjoy our first lab. If you have any questions on the lab, do not hesitate to contact me. You can email me at steve.hippemeyer@ketteringschools.org.